Hi, welcome back to Leetcode. So in this video, I am going to discuss the problem number 3960, that is frequency balance Subarray. So what is the problem statement? Problem is that you are given an integer array nums, okay? Define a frequency balance Subarray as follows. So if the subarray contains only one distinct value, it is frequency balanced, okay? That means if actually have only one subarray, suppose that subarray is content suppose to have only one 4 times. So this is suppose one subarray. So this is actually a valid balanced subarray, correct? Frequency balanced subarray. Otherwise, there must exist a positive integer f such that every distinct value in the subarray occurs either f or 2 into f, means double times, and both frequencies occurs among the distinct values. Return an integer denoting the length of the longest frequency balance array. Okay, so first of all, let's take this example one. First example 1221, then 1221, 233, 233. This is actually input array. Now, first of all, we all know that how actually we can generate all the possible subarray. So first of all, if it is starting from 1, so first it will be 1, this is one valid subarray, then 1 2, then 1 comma 2 comma 2, then 1 comma 2 comma 1, right? In this we can start, means we can take two pointer, I pointing the actually the it will point, I point will point to the actually left side of the subarray or the starting of the subarray, and j will point to the end of the subarray, what of the current subarray. So for 1 comma 1, both will be 0 comma 0. For 1 comma 2, these two elements, it will actually indicate 0 comma 1 in this way, right? Correct. So we all know how we can generate all the possible subarrays from an input array. Now actually what they are saying that extra, that if for any current subarray, suppose I actually have x, y, z, three elements, both all of these three actually are distinct. So that means uh, we will actually follow the second condition. This second condition. First condition is that for what? If the subarray contains only one distinct value, it is frequency balanced. That means suppose we actually have only x 3 times. That time we can actually know that this actually balanced subarray, so we can actually take the length of this and we can compare this actually maximum or not, right? So first of all, let's see this example first. So for this subarray, only one distinct element 1, so this actually balanced frequency subarray. So our answer is initially suppose 0. So this is actually valid. So our answer will be modified with 1, because 1 is the current maximum length we have seen till now for those that actually balanced frequencies array, right? For the next 1 comma 2, is this actually balanced? First condition, it is not true. What is the first condition? That all of the elements is same, but here we have two distinct elements. One is the 1, another was the 2. So that's why we have to follow the second condition. What is the second condition? They mention that the frequency will be f or 2f, and both should actually exist. Okay, so what is the frequency of 1? I have seen 1 times. 2, how many times? 1. But have I seen it? So suppose if I actually assumed it 1, so 2 into f, it will be 2. So have I seen any elements from this subarray whose frequency is 2? No. So this is not a balanced subarray. Got it? We will not count the length of this current subarray. Got it? So go to the next. Okay, here also we have two distinct elements. One is the 1, another is the 2. So what is the frequency of 1? It is 1. What is the frequency of 2? It is 2. Correct? Now actually if I assume that okay, if frequency is 1, so 2f it will be 2. So have I seen both of these frequency 2 and 1? Yes. For 1 the frequency is 1, for 2 the frequency is 2. So this is a balanced frequency subarray. Correct? So what is the length for this? 3. So this is the maximum length I have seen till now. So that's why I will modify the answer with 3. Got it? Next is this 1 comma 2 comma 2 comma 1. So what is the frequency of 1? It is 2. What is the frequency of 2? It is 2. So we all know that the first condition is false. That means we have actually multiple, more than one distinct element, right? So that's why we have to follow the second condition. So what is the second condition? That we have to see all the frequency f or 2f. So here actually f, suppose frequency is 2, so we should actually have 2 into f, that means 4. Do we have any element which actually frequency is 4? No. So that's why this is not a valid subarray. So in this actually I will actually check all the possible subarray, and we will take if any subarray actually is following any valid condition. So I actually take the length of the subarray and actually I will check. I will actually modify our answer. So how actually we can solve the brute force approach? So we all know that how actually we can generate all the possible subarray, that is actually n square, correct? We will take 2 pointer, one for loop for I, one for loop for j. Okay, that's fine. But between this we have to check that what is the frequency. So what actually we need to know that what is the frequency of, yes, so by using these two for loop we can actually generate all the possible subarrays, right? Now to know that what is the frequency, so first of all we need to know that how many distinct uh, numbers is present, right? How many distinct number is present. So for that I can use a set. So whenever I have seen any new element, I will actually store this in this set. So we all know that set actually store the unique element. So if I actually take the size of this set, so we will know that how many distinct element I have seen. So that why actually we need this, because we need to follow that how many, if the set size is equals to 1, then actually follow the condition 1. Else if it is greater than 1, means greater than equals to 2, at least 2 distinct elements, then you have to follow the condition 2. So that's why we need to know that how many distinct element is present in this current subarray. So that's why we can actually use set, or we can use the map also. Map also store the unique element, means key will be the number and value will be the frequency. So it is better to use the map instead of using two different set and map both. We can use the map. What is the map size? That actually indicates that how many distinct element I actually have in the current subarray. And for this each number I can actually easily find out what is the frequency for those number in this current subarray, correct? So this is the first condition or first element data structure we need, and I have already explained why you need this. Next condition, to satisfy the second condition, that if the number of distinct element is greater than equals to 2, then actually we need to know that there will be some element whose frequency should be f, and there will be some element whose frequency should be 2f. So how actually we can solve this, or how actually we can actually follow this situation, that some elements should actually have frequency f and all other elements should actually have frequency 2f. So there should be any other element that actually frequency is suppose 0.5 of f, or 1.5 of f, or 3f, or should actually either f or it will be 2f, in between of these two, correct? So what actually I can do, that if I know that how many number actually have frequency as a, plus if I know that how many numbers actually have frequency is 2 of f, okay, if I actually add this, what actually it indicates? What actually it indicates? So if I know that the frequency of each number, so frequency of each number, so I know that suppose for the number 2 the frequency is suppose f1, for number 3 the frequency is suppose f2, okay. So if I actually reverse this, that suppose we have actually another number, that is 4, again frequency is suppose f1, same as frequency of 2, okay. So if I reverse this, that how many actually number actually have frequency f1? It will indicate 2 and 4, correct? How many number actually frequency f2? That actually indicates 1, correct? If I reverse it, so if I actually add this, the frequency of f1 is 2, frequency of number whose frequency is f2, that is 1, 2 plus 1 it is 3. What actually it is? How many distinct element is present? Actually you can see that how many distinct element is present. Got it? So that's why we need to know that that how many actually to satisfy this condition, that frequency of f, number of elements whose frequency is f, and the number of elements whose frequency is 2f. If actually add this, then actually it should be actually the number of distinct elements in this current subarray. So that's why we have to take another map. In this map we will store that what is the frequency and how many numbers, correct? What is the frequency and how many numbers actually have this number of frequency. Got it? So you can just actually try to map this, that for this element 2 the frequency is f1, for the element 3 the frequency is f2, for the element 4 the frequency is f1. So if actually reverse this, that how many number actually have actually frequency f1, that is actually 2. Got it? And how many number actually frequency is f2, that is 1, only one element. So if actually sum add this 2 plus 1, it is actually 3, and 3 is the how many distinct element actually present, okay, in this subarray. So first map is to store this, that for this number 2 what is the frequency, okay. And the second map we are talking here actually, that is the frequency, how many number actually have the same frequency. Got it? So if actually add this, the frequency f1 plus f2, it should be actually the number of this map, first map size, map1 dot size. Clear? The logic is clear. So then how should you know that what is the 2f and what is the f? So 2f will be always actually the maximum frequency. So that's why I actually check the always actually counter will store a variable. What is the maximum frequency we have seen till now? So what is the maximum frequency? So how should you know this? We'll know this from this map 1, that what is the maximum frequency we have seen. Okay. So I'll find out what is the maximum frequency, and I will search for the maximum frequency by 2. So I will check that what is the maximum frequency, how many number actually have for maximum frequency, and how many number actually have maximum frequency by 2. So if I actually add this count, this 2, so I have to check that this should be actually map1 dot size, or those many number of distinct element actually I have seen in this current subarray. That should be same, correct? This is clear. So let's go to the code, then it will be more easy to understand. So first of all, our answer should be 0 by default, and n is the number of actually element present in this input array. So we all know that how actually we can generate the subarray, all possible subarray. So I will take 2 pointer, one is I starting from 0, and it can go up to n minus 1, okay. And another nested for loop, that is for the right pointer of the current subarray, that is j starting from I, and it can go up to n. Got it? N means n minus 1, sorry. So for that, for each subarray we need to know two things. One is the frequency of each number, okay, and frequency count, that how many each number actually have the same frequency, or frequency f actually have how many numbers have the frequency f, okay. And maximum frequency, I have already explained why you need to know what is the maximum frequency. It will to easily understand what is the 2f, so I can actually get the f. So these three variables actually I need to know. So I'll check that frequency of first whatever number actually currently I'm adding, the nums of j. Nums of j is the current number, it is going to add into the current subarray, going to part of the current subarray. So if the frequency is already greater than 0, that means, so what you need to adjust this. So suppose we have already sent 2 2, okay. So in the map 1 I have already stored that for this 2 the frequency is 1. In the map 2 I'll store that for frequency 1 the how many numbers will have frequency 1, that is 1. Clear? How many number? Only 2 actually have this frequency as 1, so that's why its count will be 1. Now next time actually, how am I going to add this 2 as a part of the current subarray? What will happen? The frequency of 2, it should be increased by 1. Now it will be 2, correct, in the map 1. But in the map 2, we should adjust that there is no frequency as 1, because it should be removed, because there is a 2 was actually the only one element part of that, the frequency actually was 1. So that's why first of all adjust this, first of all remove this, and then actually add into the new frequency. So that's why first of all mark this as that frequency 1, previously it was actually 1, and decrease this. Okay, so this actually reset the state. Then actually I will first increase the frequency as 2, because the how many number actually I have seen as 2 elements. So that's why map 1 actually store the value of frequency of 2 as 2. Got it? Now in the map 2 we'll store that how many actually frequency as 2, that is 1. Got it? So that's why we need to actually synchronize the actual state. So that's why we have to adjust this. Got it? And you can actually ask me why actually we are not adjusting the map 1, because we are actually overriding the value. Here actually in the map 2 we are actually calculating the value from the first map. So that's why it dependent on the map 1. So that's why first of all actually remove this from the map 2. Then actually we will store the map 1 and again actually try to store the propagate the value in the map 2. Got it? So that's why if frequency is already greater than 0, that means we have to remove from the previous frequency. That's why frequency count, whatever the old frequency of the current number, first of all decrease by 1, because currently that state is no longer no longer actually correct. So that's why I'll check if the frequency is already 0, because suppose the only one element, the frequency it was actually have the same frequency. So there is no element for the current frequency, so that's why I actually it is also removed from the map also. Got it? If it is 0, already 0. Then actually I'll actually add this current number into the current subarray. So that's why first of all increase the frequency of the current number. Then actually I have to store in the map 2 in the frequency count that for this frequency I'll actually increase by 1. That means we have seen one element whose frequency is the f. Got it? So that's why in frequency count I'll just store the whatever the updated frequency, I'll actually increase the count by 1. Got it? And now I'll store what is the maximum frequency we have seen till now. So maximum frequency of the current element, frequency of the current element, and whatever the maximum frequency we have seen till now. Got it? And I will take the whatever the length of the current subarray, that will be j minus I plus 1. Got it? And I will check what is the first condition is that if the subarray contains only one distinct value, it is frequency balanced. So that's why how to know that how many actually distinct element is present. So that actually will know what is the first map size, frequency dot size. So I have seen only one element, so our map will contain only one element. Key will be 1 and the value of the frequency of the number 1 or element 1. So that's why I'll check what is the frequency dot size. If it is equal to 1, that means only one distinct element is present. So I'll check what is the maximum length and continue. We don't need to go to the condition 2, situation 2. So if it is situation 2, then what actually have to check that? So they mention that whatever actually the distinct element actually present, that is already greater than 1. That means at least 2 distinct elements present. So either frequency of one atom should be f or 2 into f. So that's why frequency count, that means a map 2, or actually store that against the frequency how many number actually have actually the same frequency. So that's why if it equal to 2, then actually we can actually, if it is 3, that means we have same, suppose a, 2f and 3f, then it is not possible. This is not a valid situation. So that time we will not actually calculate our answer. So if it is the only 2 different frequencies present, then actually we will check is it f or and it 2f. If it is not one of them, then actually we will actually not count our answer. So that's why we'll check that frequency count dot size, it is equal to 2. Okay, then actually check that what are the maximum frequency you have seen, that should be divisible, because either it should be f and it should be 2f. So that's why what is the half maximum frequency by 2. So now to know that either it should be f or it should be 2f, then what is actually the condition that we should actually have both of these. It is not possible that, suppose you can ask me that for 1, 2, 3, here also we have more than one distinct element, but frequency for 1 it is 1, frequency of 1, frequency of 2, it is 1, frequency of 3, it is 1. So how much number actually have frequency as 1? That is 3. 3 distinct elements actually have frequency as 1. So is there any number which actually have 2f, frequency of 2f or 2? No, there is no element. So that's why it is not a valid subarray or valid balanced frequency balanced subarray. Got it? So you only counter if actually have both f and 2f. It should actually have. So there is no 2f or f. So that's why we'll check that both should be present. Half should be also present, and also the maximum frequency it should be present. Then actually we'll actually check our answer. So honestly, I will start actually count the answer. So if we add the frequency of maximum frequency and the frequency of the half, it should actually give us the how many distinct element it is present in the current subarray. So if it is actually true, then actually we'll check what is actually our answer, and with the current length of the current subarray, we'll check with our answer. Got it? So in this we will check all possible subarrays, and we will check for each valid balanced frequency subarray. We will actually check our answer. Got it? And ultimately return the answer. Got it? I hope this is clear. I have shared this code in the description. You can check that. And if any doubt, any suggestion, you will comment on that. And if you are not subscribed, please subscribe channel. Thank you. Bye bye. See you in the next video.